Now, in my previous example of completing the square, we took this expression here and we treated it as an expression, and we came up with, and I'll just write it in here, in fact. What did we come up with? I think it was x plus 2 all squared minus 11. And that there, I'll put that like that. That there's the completed square version of this expression here. But this one equals 0 here. So there's many ways of actually solving this for x. One way is to complete the square just as we did. Now make it equal to 0 and then strip away the negative 11, unsquare it by finding a square root, then subtracting the 2 and leaving us with x. So you could do all that if you want. We're going to take a slightly different approach. And let's have a look at doing that approach right now. So what was the approach I just mentioned, though? So I could take this, and in fact, let's do that now. I've got x plus 2 all squared minus 11. I'm going to make it equal to 0. So now this bit here and this bit here are the same. They're in every bit the same. So what I'm going to do now is I'm going to add 11 to both sides. There it is. So I've now got x plus 2 all squared is equal to 11. Now I'm going to find the square root of both sides. And of course, when I find the square of a side and I want, this is not the subject, this is the subject, I'm going to have to make this a plus or minus. So now the square root of the square leaves me with an x plus 2. And I've got my plus or minus root 11. Now what I'm going to do is I'm going to subtract 2 from both sides. There it is. So now x is equal to negative 2 plus or minus root 11. And there is my answer. Now, we could, of course, get there another way. The way we originally, of course, were doing was completing the square, which we did, make it equal to 0, and then solve for x, which is what we just did. But we can do it quite differently as well. Well, not quite. In fact, quite differently is completely wrong. But yet the procedure just involves a slightly different approach. Not completely different, slightly different. Let's have a look at that now. So I'm going to, in fact, I might even need a bit more room here. Maybe not. Let's see what happens. So I'm going to go ahead. So we've got our x squared plus 4x minus 7 is equal to 0. So now what I'm going to do is I'm going to add 7 to both sides, because we do have now two sides to this. So I've got my x squared plus 4x is equal to 7. Now I'm going to take the b term. I'm going to add it, so 4, and divide it by 2 and square it. Now, before, I subtracted it and then divided it by 2 and then squared it. But I've got nothing to there was no other side at this point. Now there is another side, and so rather than subtracting it, I'm just going to stick it on the other side, which is the same as subtracting it, because then if I brought it back to the side, I would subtract it. So let's go ahead and do that, and I'm going to add another of these. So I've got 4 over 2 all squared. And the reason that works, of course, is because if I subtracted this from both sides, I'd be back where I started. So let's take a look now where we sit. Well, I've got this expression on this side, and what do I have? I've got this bit here is my perfect square. So let's have a look. That's going to be an x. I've got a bracket, and I've got a square. And we know the contents of the inside of this bracket is the bit that belongs here. What is that? 4 divided by 2, just the 4 divided by 2, not the squared. The 4 divided by 2 is 2, so I got a plus 2, and that bit there turns completely into this bit here. Now, I've still got this bit on the other side. What have I got? Well, I got a 7 plus, well, 4 divided by 2 is 2 to squared is 4. And you might start to recognize this already. I've got a 7 plus 4, and of course there it is over here, and I've got my 11. There it is. All right, so what we're going to do is we're going to add these two together. So 7 and 4, of course, is 11. X plus 2 all squared is 11. Now I'm going to take the next step, and I'm going to find the square root of this side and the square root of this side. Of course, when I find the square root of this side, because it's not the subject, I make it plus or minus. Square root of a square leaves me with an x plus 2 is equal to plus or minus root 11. I'm now going to subtract my 2 from both sides. There it is. 2 minus 2, of course, is 0. Sorry, you couldn't see that very easily. X, therefore, is equal to negative 2 plus or minus root 11. And there is my solution for x. Notice we got there a slightly different way. So in the first instance, we'd already gone ahead. We hadn't done this bit here. We hadn't made it equal to 0. We weren't set up to solve. We simply found the perfect square, or if you like, we completed the square for this expression. We found a perfect square component and a bit tacked on the end. We subtracted the bit tacked on the end from both sides, leaving us with x plus 2 all squared is equal to 11. So we added the 11 to both sides. Did I say subtracted? We added the 11 to both sides. And then, of course, we just filtered it through, making x the subject and stripping away the relative components. The other way was the way we did it here, which was to start off by saying equals 0. Then we could add the 7 to both sides. We added the b term, halved it and squared it to both sides. We then took the first part of the expression, which automatically became the x plus 2, 2 being the contents of that squared bracket, just the contents. We squared it and we made it equal to the other side. Then we stripped away the components. We added them together. We stripped away the square root. We stripped away the plus 2, and we were left with the answer. So that is the other way of doing that. All right, let's take a look at a few more of these.